This is Earth, the blue planet, the only place in the known universe with persistent liquid water. Unfortunately for us land animals, oceans make up the majority. Only a tiny 2.5% is fresh. Of all the fresh water, about 70% is frozen in glaciers and ice caps, and about 30% is groundwater. What's left is the fresh surface water, about 0.03% of our total supply. Again, 70% of this is frozen in ground ice and permafrost, and about 3% is atmospheric. This tiny bit, only 0.0084%, is what supports the vast majority of human activity. Collectively, we use a lot of water. In the US alone, 870 billion gallons is used every day. That's 1.5 times the volume of Mount Everest every day. We're very good at taking what we want and very bad at putting it away. About 90% of the water that we use needs treatment before it can be reused. Conventional wastewater treatment usually involves multiple steps designed to remove one particular type of molecule. And even then, some contaminants such as antibiotics and microplastics prove difficult to remove. What if there was a way that we could remove all of the contaminants from wastewater with a single treatment? To assist us on this monumental task, we enlisted the help of our microscopic friends, bacteria, and some very cool structures they build, flagella. Flagella are actually a polymer made up of many flagellin monomers. These little proteins stack together in a lovely spiral to make up a long, very stable filament. Each flagellin is comprised of 4 domains: the D0, D1, D2, and D3. The D0 domains stay together on the inside, while the D3 domains stick out into the world. For this reason, the D3 domain was most interesting for us. What we can do is replace the DNA that codes for the D3 domain with another sequence, an enzyme, a heavy metal binding protein, or even GFP. We can take this new sequence and give it back to the bacteria and ask them to make thousands of copies of our new fusion protein. We can lyse the cells and collect our proteins, and in vitro assemble a new flagellum on our specially modified cellulose membrane. Now, instead of the D3 domain on the outside, our filament is covered in our protein of interest, and that is pretty awesome. But what if we use a mix of different functionalized flagellums? Our flagella become modular, multifunctional, and way more awesome. We have a filament that can degrade microplastics, inactivate antibiotics, and bind heavy metals, and grow a forest of these functionalized flagella. Adjust the monomer mix to specific contaminant levels. We can grow them on any shaped substrate, and make an already large surface area enormous, and build a bioreactor that revolutionizes the way we treat difficult to remove contaminants. We live in a time where sci-fi is constantly becoming sci-reality. This is how we used our brain. How will you use yours?